Hello and welcome to this short video about solving equations where your unknown is part of the denominator of a fraction. We've got a couple of examples here. 5 over x is equal to 15. Now what we're always going to do is think about how we solve normal equations, so doing the opposite of what's already there. At the moment we're doing 5 divided by x, and it's hard because x is on the bottom. We always want to have x on the top. So at the moment it's telling me to divide by x, so I'm going to times by x to start with. When I times both sides by x, the left hand side is now just going to be 5. The reason I times by x is to get rid of it from the left hand side. I don't want it on the bottom at all, I only want it on the top, and by timesing by x I'm getting rid of it from the bottom. And I have to times the right hand side by x as well. So I get 5 is equal to 15x. Now if I want x on its own, I need to get rid of that 15. At the moment it's times 15. So I'm going to divide by 15. So 5 over 15 is equal to x, which if you wanted to, you could simplify to x is 1 over 3, or 0.3 recurring. There's another example here as well. It's a little bit harder, but not too much, a little bit harder. 3 over x plus 2 is equal to 7. First thing I'm going to do is multiply by what was there on the bottom. So last time it was times x. This time I'm going to times by x plus 2. And the reason I'm putting it in brackets, I have to remember to times everything by 7. So same idea as before. When I times by x plus 2, I just get rid of it from the bottom. And on the right hand side, I'm going to have 7 lots of x plus 2. Which I can multiply out to get 3 is equal to 7x plus 14. Now I just have a normal equation that I've seen lots and lots of times before. I need to get x on its own. We sort out the adding and taking before the timesing and dividing, thinking about teenager method, backwards bid maths, whatever method you've seen before. So if I take away 14 from both sides, on that right hand side the 14 just goes away, that's why I'm taking away 14. 3 take away 14 is minus 11 or negative 11. So negative 11 is equal to 7x. I want to get the x on its own, so I'm going to divide by 7 to get minus 11 over 7, which obviously you can turn into a decimal if you want to, is equal to x. So we've just got a couple more examples. Let's say exactly the same type of question as I had a minute ago. So I'm going to multiply by 3x minus 2. So 6, it just gets rid of it on the left hand side, is equal to 10 lots of 3x minus 2. Multiply it out. So 6 is equal to 30x minus 20. And then I want to plus 20 to both sides. So 26 is 30x. Divide by 30, and I get 26 over 30 is equal to x, which you could simplify to 13 over 15 if you wanted to, or put it on your calculator to get a decimal equivalent. Now this next one just looks a little bit harder, but we're going to be doing exactly the same sort of thing. Multiply both sides by x minus 2, so I get 10 lots of x minus 2. Multiply it out, so x plus 3 is 10x minus 20. Now I've got x's, unknowns, on both sides of the equation. If you remember, what we do to deal with that is we get all the x's together. So I could take away x, or I could take away 10x. I'm going to take away x because it's easier to have a whole number answer. So if I take away x from both sides, on the left hand side I'm just left with 3. Remember, the x is different to a number, so it doesn't affect that 3 at all. I'm only taking away the x. On the right hand side I've got 9x, 10x minus 1x is 9x. And it doesn't affect the 20 because there's no x on it. Now we've got back to the situation that we've seen lots of times before. Plus 20 to both sides. So 23 is 9x. Divide both sides by 9. So you get 23 over 9 is equal to x, which again you could change into a decimal on your calculator if you wanted to. I hope that helps. Thanks very much.